Yes, am I audible, Abdul?
Yes, ma'am.
All right. So in the last class, we had started with differentiation. We have completed differentiation.
Yes.
Now, one question I just wanted to discuss with you before we move on to this. Yes, Pudeja, where were you? You were not attending classes?
No, ma'am, actually, I had some internet issues, so that's why.
Okay. See, now t is equal to under root x plus 3. This is, you have to calculate the speed at t is equal to 2 seconds and time when the body stops. So see, in the last class, we had seen a similar type of question. It's just that the equation was different. Now see, if you have equation t is equal to under root x plus 3 like this. Now you have to find out the speed. So we know for speed, we have to have the equation of position, of which we'll perform differentiation. So, but now x is present here. We cannot differentiate time. We have studied, no? Differentiation of time will not provide you any equation of speed. So what we do, if we square both the sides.
Yes, ma'am.
So this root will at least get cancelled. So this becomes t square is equal to x plus 3. Now can you have the equation of x as t square minus 3? Now this is a relevant equation of position which you can differentiate further. See, d velocity will be dx over dt. So yes, this is differentiation of t square minus 3 over dt. Yes, Abdul, t square. How do we differentiate it?
T raised to 2.
T raised to 2 is there in the question. How do you solve it?
Yes. T raised to 2 into
Into
2 into
2
2t
into t to the power 2. Something else is also there.
minus 1.
Minus 1.
2 minus 1.
Minus 1 in the power, right? Minus. And when you differentiate 3,
0.
0. Perfect. Very good. So velocity is 2t because to the 2 minus 1 is 1 already. And we have to find out velocity at t is equal to 2 seconds. So see, at t is equal to 2 seconds, velocity will be 2. Instead of this time, we have 2. The final answer is 4 meter per second. This is our final. And see one more thing. It is saying when the body stops. So when you make v as 0, for when it is asking you when the body stops. So last question also we had seen where we had put velocity as 0. That means 2t is 0. That is t is also 0. This is the time. This is the velocity. A revision also of what we have done. Now we'll start with velocity. We were doing speed, no, every time. We were just talking about distance, differentiation of position. Now we'll just have, it is very similar to speed. It's just that it becomes vector form. Quickly note down this question, then I'll discuss speed, velocity with you.
Ma'am, may I know what was done in the last class after distance and displacement?
Where have you attended the classes, Khudeja? Till which topic?
Till distance and displacement.
Okay. See, after distance and displacement, we had started with speed. Velocity we are going to do today. So speed is completed. And in between speed, no, this concept is required, which I have told you, differentiation. So we have completed differentiation also. You can do one thing, take the video lectures. There are 2 video lectures, I think 2 to 3 video lectures. Take it. Speed and differentiation, at least last 2 videos you should see. Because many things will get repeated in velocity. So don't worry about that. But basic differentiations class, no, last class which we had, take the recording. Contact the management, ask them for the recording of Tuesday's class. All right.
Okay, ma'am.
Because without differentiation, you'll be having lots of difficulties in this lesson. Integration is left, so integration we can cover together, but differentiation is being covered. Done? Now see, coming to velocity. So what have we discussed about speed? Speed is basically rate of change of distance. See, distance and displacement you have covered, no, with me?
Yes, ma'am.
Okay, so you know the difference between distance and displacement. When distance, which is a scalar quantity, it changes with respect to position. Certain distance is being covered in certain time, then certain distance is being covered in certain time. So this rate of change of distance per unit time, this is called as speed. That is, everything is scalar. Speed is also scalar, distance is also scalar. But when we talk about displacement, rate of change of displacement with respect to time, that is what is meant by velocity. So displacement is a vector quantity, so velocity is also vector quantity. After this lesson, we'll start with vectors first, where you'll understand the vectors term better. Now again, speed were also of two types, velocity will also be of two types. But in velocity, we have uniform velocity and non-uniform velocity. So if velocity changes with respect to time, right, that is when displacement changes with respect to time, we obtain velocity. Now, if equal displacement is being changed in equal intervals of time, then we say it's uniform. when we are talking about vectors, in vectors, you have two quantities, right? So when you're having two quantities, you are having two components of a quantity. That means its magnitude or its direction. All right. Now, if both the quantity, magnitude and direction, they remain same, we obtain uniform velocity. If either of them, magnitude or velocity, or both, the magnitude and direction, both of them change, then we obtain non-uniform velocity. See, it's like 5 meters is being covered in 1 second. Then again 5 meters, this is being covered in 1 second. Then again 5 meters in 1 second. These are all the values of displacement. Now you can see velocity is displacement upon time. So this is 5 by 1, which is 5 meter per second. So this is also 5 meter per second. This is also 5 meter per second. So it means it is uniform throughout. Why? Because direction is also same. Direction is pointing towards the right. So direction is throughout pointing towards the right. In a circle, you can take the example when the direction changes. See, in your circular motion, laws of motions end towards the end of laws of motion, we will study about circular motion. There, the direction of velocity, it is actually tangent to the circle. So for every tangent, every point of this tangent, you are getting a different direction. So it means it's a non-uniform velocity. Either the direction changes. In this case, what is happening? Direction is changing. Let it happen, let be this, it can happen that the speed is 3 meter per second here, 3 meter per second here, 3 meter per second everywhere. But still the direction is changing, so it is non-uniform. Or it can happen, magnitude is also changing. Here it was 3 meter per second, then it became 4 meter per second, then it remained 4 meters per second, and it came back to 3 meters per second. This is also non-uniform. Otherwise, in a straight line also, let's say 5 meters is being covered in 1 second. Then 6 meters is covered in 1 second. Then again 5 meters is covered in 2 seconds. And these are the different values of displacement. So magnitude is changing here, right? So it's a non-uniform velocity case. Here direction is remaining same. You can say direction is same, magnitude is changing. Here direction was also changing, and we got a case where magnitude was also changing. So this is what is meant by uniform and non-uniform. Uniform means this is same is for speed, but it's just that in speed, remember, we are referring to distance. Wherever the term displacement I have used, we are referring to the term distance. In speed, in velocity, we talk about displacement. Now, in non-uniform velocity, you have two methods to solve the questions. Same way, in speed also, you have two methods to solve the questions. You get two kinds of velocities. This, let me discuss. See, if a particular time duration is given, time duration means what? You have a starting and an ending. Like, let's say from 2 seconds to 3 seconds, from 4 p.m. to 5 p.m., from Monday to Wednesday, from 8 seconds to 10 seconds. You are having a duration, a starting and an ending. In that case, you will use average velocity, where you take the difference of the displacement over difference of time. One case you get where you have to calculate exactly at a particular second, 0.001 seconds, exactly at t seconds, calculate the velocity at 2 seconds, like this question, which we had just seen. Their velocity was variable and you had a particular time instant, that is at t is equal to 2 seconds, you have to find out. There we perform differentiation. So both of these come under non-uniform velocity. Average velocity's formula is exactly same as that average speed. Average speed's formula was what? Total distance divided by total time. Average velocity is total displacement by total time. Let's we'll practice some questions from this, but do one thing. Firstly, note it down, then let's practice certain questions from this. Make the heading, separate heading as velocity. Quickly note down this. See one question. This question says, man starts walking from this point A, covers 10 meters to this point D, then again covers 5 meters to point C and comes and covers these 3 meters to point B. This duration is 3 seconds, this duration is 5 seconds, this duration is 2 seconds. Now we have to find out the average velocity. For the average velocity, we have the formula total displacement by total time. Let's do one thing. Let's compare both average speed and average velocity. Here, let's calculate average speed. Here, let's calculate average velocity. All right. Yes, formula of average speed is total distance by total time. What is the total distance, Khudeja? Total distance that is covered here. Figure is already given to you.
18 meters.
18 meters. Very good. Why? Because from A to D, 10. Then from D to C, 5 meters. Then back from C to D, this is 3 meters. Divided by total time taken for Teja. This also you answer. Total
11.
time. 3 seconds plus 5 seconds plus 2 seconds.
10 seconds.
10 seconds. So this is 18 divided by 10, which is 1.8 meter per second. So this is total distance by total time.
Time.
Now, yes, Abdul, you tell me what is the total displacement?
Total displacement.
Total displacement. Displacement is the shortest path. Just join initial and final point. But the person starts walking from A point
15.
and comes to here. That is this. How much?
15, right?
15 is this total.
Oh, yeah.
So final point is this. B, the person goes like this and stops at B point. No, goes like this and comes back to B point and stops here, right? In the
15.
distance, that's why we have included this 3 meters also, no, these 3 meters, because
Yeah.
3 meters also he turns back and covers. So initial point is A point, final point is B. How do we calculate displacement? Just join initial and final point. What should be this separation? This is your displacement. When you're saying 15, 15 is the total.
13, 1, 3.
Why 13?
10 plus 3.
Hmm?
10 plus 3.
10 meters are till here only. This is 10 meters. This is 5 meters. This is 3 meters. Now tell.
So 18.
18 is the distance. You are taking the entire separation. Is this part 18? Your displacement, when we talk about displacement,
28.
you're just adding
Yeah.
this entire separation A to C. See, don't hurry up and answer. Listen. A to C. How much is this? First tell me. A point to C point.
15.
15. So how can you say A to B is 18, 28 and all more than 15? A point to B point. Total is 15.
Yes.
But I'm not asking you separation from A to C. Displacement, how do we calculate? From initial to final point. Initial point is A. Final point is B. We don't care about how the person has moved, whether the person has covered or touched your C point or not. That is none of our concern when we are calculating displacement. For displacement, we just need initial and final point. If A to C entire is 15, I don't want you to include this. How much is left?
10.
10 is A to D. Is this your displacement? Is your displacement AD? Which are the points for displacement?
A to B.
A to B. And 10 meters are just till A to D. Then I'm giving you a hint, no? Entire is 15 meters, right? A to C. And B to C is 3 meters. How much do we need? We just need A to B. Total is 15. You don't need this part. You just need these two parts. Yes, Abdul. Keep on answering. Then only you'll be able to understand these types of questions and you'll be able to solve it on your own. A to C is 15. Just tell me one thing. A to C is 15. Do you agree?
Yes, sir.
B to C is 3 meters. This is also you agree?
Yeah.
Do we need this 3 meters in our calculation?
No.
Then how much is left now from A to B? Total is 15. You have taken 3 from here. A to B is how much?
Well.
Well,
Okay.
see, Abdul, just see. Now I think you'll be able to understand. This part, this is 15 meters, right? 10 plus 5. That is A to C. Clear?
Yes.
Person comes back. This is 3 meters. And this is our point B. If this to this is 15 and he comes back here, so how much is left? 15 minus 3, that is 12. Now it's clear? Clear or not?
Yes, sir.
Clear? So question was very easy. It's just that you have to understand the concept of displacement and distance. All right, whenever displacement is our shortest path. See, that is why the question was just asking you average velocity. Why are we discussing both the parts? Because you understand the difference between average speed and average speed. We took the entire distance. We added this 3. Right now, we are subtracting this 3. Right, so this becomes 12 by again 10. That is 1.2 meter per second. 10 by 10. Because total time is 10. So total displacement by total time. Quickly note it down. Yes, class, did you try the question? I think it's sufficient time. Let us discuss this now. See, it says that a man walks on a straight road from his home to a market, which is located 2.5 kilometers away. So please understand this question very well. It's basic. It's the last question from this section. Then I'll start with acceleration now. This is home. This is the market. The separation is 2.5 kilometers. Now, what's the next? What's next? It says with a speed of 5 kilometers per hour. Means the person has started from here, going till here. First, the person is moving with a speed of V1 is 5 kilometers per hour. That's the speed when he is moving. Then what happens? Finding the market closed, he instantly turns and walks back home with a speed of 7.5 kilometers per hour. When he was coming, he was moving with 5 kilometers per hour speed. But when he is returning, V2, he is returning, the speed is 7.5 kilometers per hour. Separation is still the same, 2.5 kilometers. Separation between home and market won't change. No, that separation will be the same. Now, what do you have to find? You have to find the average speed, average velocity for 0 to 30 minutes. Now the time is given. How do we know at which time the person is situated exactly there? So let us see from home to market how much time it takes for the man. So at least we'll have an idea where does 30 minutes lie, where will 40 minutes will lie, right? So let us calculate the time taken from home to market. So separate, how do we calculate the time? See, speed is equal to distance upon time. So time will be distance upon speed. What is the distance? Distance is 2.5 kilometers. What's the speed? 5 kilometers. So that becomes half an hour. How much is half an hour? How many minutes? Half an hour consists of how many minutes? You don't know how to convert. 30 minutes. Very good. 30 minutes, half an hour means 30 minutes. No, we use half an hour so much in our common language. Half an hour later, this will happen. 30 minutes later. So 30 minutes. So now you have a certain idea. From home to market, it will take 30 minutes for him to move, right? From home to market, it will take him 30 minutes. What is the first part asking? First part is asking you this only, 0 to 30 minutes, calculate average speed or average velocity. It means indirectly the question is saying that from home to market, that is from H to M, calculate average speed and average displacement. This is this distance. See, distance and displacement. Can you notice if the person starts from home and goes to market, distance is also 2.5 kilometers and displacement is also 2.5 kilometers. So whether you calculate average speed, you calculate average velocity, distance is equal to displacement. So your average velocity will be this. So velocity average, this is the first part, will be total displacement or distance. Both are 2.5 kilometer. What is the speed? What is the time? Sorry. Total time covered is half an hour. Or I can write it. This is 2.5 kilometers. I'm not writing 30 minutes because upper unit is in kilometers. So I have to write the same unit. So I'll write 0.5 hours. So 5, that becomes 5 kilometer per hour. This is the average speed, average velocity both. This is average speed also. This is average velocity as well. Why? Because distance is also same, displacement is also same, right? Now, next, second part says 0 to 40 minutes. This is something different, 0 to 40 minutes. Okay, 0 to 30 minutes, this was understood because it was a proper distance. This much takes 30 minutes. Now, how will we find out? Let's do one thing. We know from home to market, it's 30 minutes. I have calculated. Now, if speed has changed, the person has increased his speed, no, from 5 kilometer to 7.5 kilometer. 5 kilometers he was moving. Now he's coming back with 7.5. So if this is the difference, then the person's time will also change. If you are moving with a slow speed, time will be more. If you increase your speed, if you hurry up, time will also be less. If the person is moving fast, 7.5 kilometers, now the time taken from market to home back, it won't be exactly 30 minutes. It should be less than 30 minutes. Do you agree with this statement, Hudeja and Abdul? Yes or no? Yes, Abdul, clear? What am I saying?
Yes, ma'am.
Okay. Let me know whenever you want me to repeat. Fine. So let us first find out how much is the separation or how much is the distance taken when person moves back to market. So from market to home we are calculating. So what is the distance? Distance is still 2.5 kilometers. But what is the speed right now? Speed becomes 7.5 kilometer per hour. So what is the time? Distance by speed. 2.5 by 7.5, that is 1 by 3 of an hour. 1 by 3 multiplied with 60, that becomes 20 minutes. See the difference. Distance is same because of changing the velocity. Now, obviously, you have increased the speed. The person is walking fastly. So time will be less. He reached the home 10 minutes before. And when he was going from home to market, it took him 30 minutes. When he is going from market to home, it's taking him 20 minutes, right? So if it is taking him from home to market, see, this is home, this is market. If entire separation is taking him 20 minutes, it means half of the distance will take 10 minutes, half of the distance will take 10 minutes. Yes or no? First tell me this. Half of distance will take 10 minutes each. Total is 20. So midway it would be 10 minutes. Yes or no?
Yes.
Now we want to find out 40 minutes. 0 to 40 minutes the question is saying. Question is not saying at 40 minutes or at 30 minutes like this. Question is saying from 0 to 40 minutes. Means from the starting till 40 minutes. See, when the person has started from home and he is going to market, it takes him 30 minutes. This is point H, this is M, let's say this is point O. Fine. Abdul, can you tell me after 40 minutes, out of all these 3 points, where the person will be? See, at 30 minutes, he's to market, from home to market, 30 minutes. At 40 minutes, where will he be? Hudeja?
Between the home and market.
Between the home and market, that is at point O. See, Abdul, from home you have started moving. You reach market. Just take it on your own. It took you 30 minutes. Then you are returning. So 30 minutes, how much time has been elapsed till now?
30 minutes.
30 minutes, right? Now
Yes.
you are returning from market to home. And that is taking you 20 minutes. So if we take total, that becomes 50 minutes. But am I asking 50 minutes? No. It means this isn't 20 minutes. So again, let's start. From home, you have started moving. You have reached market. It took you 30 minutes. Then on midway, this midway between total time taken going back was 20 minutes. So half of it would be 10 minutes. Do you agree with this statement that this half would be 10 minutes and this half would be 10 minutes?
Yes.
So if from home you have started, you were moving, you came here. It took you 30 minutes. And then you are returning till this point. Now how much time has been elapsed? 30 and
10 more
10.
minutes.
So total
40.
40. Now you got the concept?
Yes, ma'am.
Okay. So that's why we are taking, it means the person is in middle of the road. Middle of road means middle of home and market. That is in between home and market. So now once we know the points, why are we calculating? Because we want to find out distance and displacement. And without knowing our initial and final positions, how will we calculate? Right. So what do we have for the B part? Home, market, total, this was 2.5 kilometers. While returning back, this would be half of 2.5, 1.25. Now see, when you are calculating the average speed, for average speed, you take the total distance. Total distance means entire path that is being covered, whether the person is coming back, going to market, coming back to home. You will consider everything. So the person is moving. So 2.5 here, 1.5 here. This is the final point. This is the initial point, home. This is the final point. So total distance will be first 2.5, then coming back to 1.5. That is 2.5 plus 1.25 kilometers divided by how much time? 40 minutes. That means by total time would be 0 to 40 minutes. 40 minutes would be 2 by 3 of an hour, right? So this is 2 by 3 of an hour. So 2.5 plus 1.25, this becomes 3.75. This 3 will go up by 2. That becomes 5.12 kilometer per hour. This is the average speed. Will the same be the average velocity, Abdul?
I couldn't hear you.
It will be same.
No, I couldn't hear you. What did you ask?
I'm asking average speed came out to be this. Will
Yeah.
average velocity be this same quantity?
No, ma'am.
Why? Reason? In the previous part, when we were solving A part, we had taken average speed and average velocity as same 5 kilometer per hour. Why not this? Why not 5.12? You've not understood, Abdul. See, how do you what is the difference between average speed and average velocity? I have repeated so many times. For Deja has missed certain classes, I understand. But you have been doing the classes. You tell me there is one difference between average speed and average velocities formula. One thing.
Average speed is total distance upon total time.
And average velocity is? Check. See, you must have written. Turn the pages. By now, I think you should have remembered all the formula. Total displacement by total time is average velocity. And here the distance and displacement are not same. So you will not have average speed and average velocity as same. In the previous question, initial point was home, final point was market. So distance was this part. Displacement was also this. So we got the same answer. Right now, distance is this entire part, but displacement is just this. So we have different values of distance and displacement. So this time it won't be same. Khudeja, you tell me, what is the displacement here in this question right now?
Is it 1.25?
1.25 because it's 2.5 minus 1.25, right? This part is also 1.25 only, no? Divided by 2 by 3, so that becomes 1.87 kilometer per hour. Note down this question. It's an important question and it sometimes repeats itself also. It's a very old question. Note it down. Wherever doubts you're having, let me know. After this, we'll do instantaneous one, which we have already discussed, just basic formula. Done. Now, see, regarding instantaneous velocity, this was average velocity. Instantaneous velocity is same as that of instantaneous speed. You have to find out, you have to differentiate dx over dt, like 3t square plus 2t minus 1. When you have to find the velocity, so dx over dt we'll find out. So that means 3 into t square. So how do we differentiate t square? You put 2 here. Khudaija, let me tell you it in brief. If x to the power n is there, we write this as n x to the power n minus 1. So here it is t square. N is 2, right? So 2 variable is t to the power 2 minus 1. This is how we differentiate. Check up the video so that you can properly see it in detail. This is t to the power 1 already. So this becomes 1 minus 1. This is 0. So this becomes 6t plus 2. And at t is equal to 1 seconds, you put the value as 1. So that becomes 8 meter per second. This is how we find out. Abdul, you will be able to understand, but Khudaija will be having difficulty in this because the differentiation is not clear. But just make a note and write instantaneous velocity. Check the lecture, you will be able to understand. Just contact on the days you have missed. No, just take the videos. You can forward for the parts where time is being taken. Just forward it, take the notes. Whichever part you have not understood, note it down. Now we'll do acceleration. We'll start with acceleration. Note it down first. Now see, the way we have been studying that rate of change of velocity, this is a rate of change of distance is speed and rate of change of displacement is velocity. Now, if velocity changes with respect to time, let's say velocity was 5 meter per second in t is equal to 1 second. Then velocity was 5 meter per second in t is equal to 1 second. So what is the rate of, you can see velocity is changing with respect to time. Now, this was 5, 5. Let's say this is 6 meter per second in 1 second. So it was 5, 5, then it became 6 meters per second. So if it becomes 6 meters per second, 5, 5, and then 6. It means velocity has changed. Initially it was 5, now it has become 6. So there is a change in velocity. This is what we call as acceleration. So acceleration is rate of change of velocity per unit time. So this is velocity per unit time, acceleration. This is the formula. And again, it's a vector quantity. See, SI unit. Speed is meter per second, and again time is there, so it becomes 1 more second. That becomes second square. See, meter per second into this second, so that becomes meter per second square. And if you want the CGS unit, that becomes centimeter per second square. Now, acceleration is also of two types, uniform, non-uniform. In non-uniform, you have average and instantaneous. Same thing. This repeats on this lesson. Okay, so SI unit is meter per second square. CGS unit is centimeter per second square. Let's see one basic question. Initially, the velocity was 2 meter per second. Then the velocity became 5 meter per second in 10 seconds. So what is the acceleration? Acceleration is change in velocity by change in time. Change in velocity means final minus initial velocity by final minus initial time. So final velocity is 5, initial velocity is 2, time is 10. So this becomes 3 by 10, that is 0.3 meter per second square is the acceleration. This is how we calculate acceleration. Uniform and non-uniform acceleration, these are also very similar to velocity. See, if the change in velocity is constant, means here the change in velocity is 3 meter per second and time duration is 2 seconds. Here change in velocity is 3 meter per second. Time duration is 2 seconds. Here also change in velocity is 3 meter per second. Time duration is 2 seconds. This is also change in velocity is 3 meter per second. Time duration is 2 seconds. See, in every part, acceleration you calculate 3 by 2 meter per second square. Take this part, calculate acceleration. This becomes 3 by 2 meter per second square. It's uniform throughout. The value of acceleration is constant. This part is very important for you because you have uniformly accelerated motion equations also. This we'll do in the next class. And regarding non-uniform acceleration, the change in velocity is variable. Initially, let's say the velocity is changed by 3 meter per second in time 1 second. Then the change in velocity is 4 meter per second in time is equal to 2 seconds. Let's say time remains same, but change in velocity, this is different. Or let's say the time is changed, the magnitude of velocity has suddenly increased 6 meter per second. Now calculate acceleration. This acceleration is 3 by 1 meter per second square. This acceleration is 4 by 2 meter per second square. So it is constantly different, changing. So magnitude is also changing or direction can also change. This is what we call as non-uniform acceleration. Note it down from here. Make the heading as acceleration. Acceleration is a very small topic. This is just it. We'll practice 1 or 2 questions and it is it. Because everything is similar to speed and velocity. See, we studied distance. Distance gave rise to speed. Change in speed gave rise to acceleration. Similarly, we studied displacement. Rate of change of displacement became velocity. Change of velocity is acceleration. So whatever you have studied earlier, those things are exactly same for acceleration with just the velocities formula. Right? Note it down. If few people have completed till here, you can leave. In the next class, now we'll do uniformly accelerated motions equations. That part is left, which is important, and then motion under gravity, which will complete this lesson. So it won't take a lot of time to complete this lesson, but please revise this part. And for Khudaija, please have a look at the video lectures, all right, so that you don't mess up with this acceleration portion, because differentiation is here also. All right. Thank you so much, class. You can leave. You don't have any assessment to do.